Today we're going to learn to develop your fluency in multiplying. So I know that you guys know what multiplying is. We're just going to revisit it quickly and then do some practice in one of your times table books that you have at home. Okay, so just a reminder that multiplying is really just repeated addition. So when we're speaking about multiplying, you are just trying to work out how many you have, but you have equal groups that you're sort of putting together. So what we have here is if we were trying to work out how many counters we had, if we wanted to write an adding sentence, which we could write 3 plus 3 plus 3 plus 3 equals, okay, and that would work totally fine. But we could also realize that we have 4 different sets of 3, or 4 lots of 3, or 4 groups of 3, and that we could write this as a multiplying sentence because all of these groups are the same size and we have 4 of them, so there's 4 lots of 3, so 4 times 3, and we could work out what it is that way. Okay, just a reminder that we'll do that after. I've got my groups out like this. They're a bit scattered, but if you'll remember that what I really like when we're multiplying is I like to build an array because I find arrays really visual and I think that they really help us see how many we have all together. So I'm just going to put these in a nice beautiful array, which is what this is here. I'm just going to draw a line so that we know. So the picture that represents a multiplying sentence is called an array. So this here. So we have 4 lots down, or 4 sets down the side. So we've got 1 set, 2 set, 3 set, 4 set. So we have 4 and we have 3 in each set. 1, 2, 3. So our multiplying sentence becomes 4 times 3, which is we've already written over here. Okay, we can work it out ourselves. We can skip count in 3s. You can figure out that there's 6 here and another 6 and add them together. You can use number rods to do it. So we have 4 lots of 3, so I need 1, 2, 3, 4, and put them in a number track. Or maybe you look at that multiplying sentence and you already know that that is 4 times 3 is equal to 12, perhaps. Okay, a reminder that the answer to a multiplying sentence is called the product, okay? So if you have an answer to a multiplying sentence, it's called a product. So the product of 4 times 3 is 12. All right, so all of this is stuff that you have seen and done before. It's just a reminder of how multiplying works and what multiplying is. Okay, if we wanted to explore the commutative property of multiplying, which is I think something that you guys should know about, but just it's nice to have a wee reminder. So the commutative property of multiplying is great because it helps us solve all sorts of ones that look a little bit tricky. We'll just use our same example here. So we had 4 lots of 3 and we'd written that out. So we had 4 times 3 equals 12. And you guys told me that that's what that was. Okay, because we have 1, 2, 3, 4 lots of 3 down here, and we have 4 down the side. So we have 4, I can't see that though. So we had 4 sets and 3 in each set. So we had 4 times 3. Now, if we're thinking about multiplying, there's this beautiful thing. It happens in adding as well. But if I wanted to rotate this, so if I highlight all my whole array here, and I just give it a quick rotate. Oh dear. Now I don't have 4 times 3. Now I have 3 sets. 3 sets. I've got 1, 2, 3. Okay. And I have 4 in each set. 1, 2, 3, 4. It's not the same, but it is the commutative. And you'll have noticed that I haven't gained any or lost any counters. All the counters remain the same. So you're right, I still have 12. I've just flipped it on its head. So instead of having 4 lots of 3, I now have 3 lots of 4, or 3 times 4. And I haven't lost or gained any counters, so I still have 12. And we can check with the number rods. We can have 3 lots of 4 here, and we can check them in the number track. And I'll just put my 4 lots of 3 underneath it just to show you that they are in fact equivalent. Okay, they're not equal because 4 groups of 3 and 3 groups of 4 are not the same thing, but they do result in the same answer because of the commutative law of multiplying. And so if you end up with a question that seems a bit daunting, like for example, say we've got 9 times 3, for example, or 8 times 3. So say you end up with a question that is 8 times 3 one day, and you go, oh, I don't know my 8 times table, I don't know. Fine, flip it on its head. Just flip it round. 3 times 8 instead, and then all of a sudden it seems a little bit less daunting. So that, because you probably do know your 3 times table, so instead of struggling to figure out what your 8 times table is, just flip it on its head to be your 3 times table. So that is the commutative law of multiplication. So just as a point here we have 8 groups, so 1, 2, 3, 4, 5, 6, 7, 8 of 3 in each group across the top. Whereas if I just rotated this round, then all of a sudden I have 3 groups and I have 8 in each group. And again, the number of counters did not change. It's just this beautiful thing called the commutative law of multiplication. Now, what we're going to do today is we're just going to do a lot of practice. So I'd like you to get a times table book that was in your pack, and I'd like you to complete half of the pages in it. Okay, so not the whole thing, just half of the pages. You can go and look at Mr. DeMeo online to see if you like his times table videos to help you remember them, but we're just practicing our times tables to get a little bit quicker with them today. Okay, thank you.